In this video, we're going to talk about two new terms called domain and range, and then we're going to actually practice identifying the domain and the range of different functions. So we'll be looking at those mapping diagrams, graphs, tables, etc. So before we can actually find domain and range, we need to define what they are so we know exactly what we are looking for. The domain on a graph is the set of all possible input values of a function. So any values that can be put into a function. Typically what we're looking for are all possible x values that can be put into that function. Remember, x is typically input, so when we're finding the domain of a function, we're finding all of the possible input or x values. The range, on the other hand, is the set of all possible output values of a function. So typically what we're trying to find are all of the y values, all of those output values that come out of that function. So when we're finding domain and range, we're finding all of the possible x values or input values and all of the possible output values or y values. So let's start by identifying the domain and range of some functions that we've already seen. So here we can see we have two different representations of a function, and what we're going to do for each is we're going to identify the domain, which remember are our inputs. So I have the domain, which are the inputs, and the range, which represents the outputs. And what I'm going to do for each is I'm going to identify the possible inputs or the x values and the possible outputs or the y values. So to start, I'm going to put x equals and y equals to remind myself that I'm finding x and y values for my inputs and my outputs. Then I start with each point. So this point right here is the point x is -3, y is -2. So my input for that particular point is x is -3, and my range, which is my output, is y is -2. Then if I go to my next point, here I have x is -1, y is 0. So my input is -1, my output is 0. I go to the next point. This is x is 1, y is 2. So my input is 1, my output is 2. And then here I have the point x is 3, y is 4. So my input is 3 and my output is 4. So I simply list all of my input values for domain, or all of my x values, and all of my output values for my range, which are my y values. Then if I look down here at this second example, what I see is a mapping diagram, and I know that mapping diagrams are rearranged with inputs in one oval and outputs in another. So here I see all of my inputs grouped together. So really what this is saying is, okay, my domain is all of the x values inside of this inputs bubble. So that's -3, -1, 1, and 2. My range are all of my output values or my y values, and they're in this outputs bubble over here, which are the values of -2, -1, and 0. So we're going to go through the same process here. We're just going to identify our domain and our range for each, noticing that my domain are all of the x values and my range are all of the y values that we have. So my domain, if I look at each point individually, this is the point x is -2, y is 4. So if I go over to my domain, my input is -2, my output is 4. The next one is x is -1, y is 2. So my input is -1, my output is 2. Here I have the point 0, 0. So I have an input of 0 and an output of 0. Here I then have the point 1, 2. So I have an input of 1, and then I notice I have an output of 2, but I already listed that here, so I don't need to list it again. So I'm not going to repeat it. I just know that I've already included that in my list of outputs. Then here I have the point x is 2, y is 4. So I have an input of 2 and an output of 4, which I can already see that I've listed, so I'm not going to repeat it again. Okay, the next one I see is I see a table, and luckily it's split up into x's and y's already, so I have my inputs and my outputs. And what I'm going to do is list my domain and my range. Remember, my domain are all of my x values here, So I see x could be equal to -3, -1, 0, and 1. And my range are all of my y values. So remember this is x and that's y. My y values are 3, 1, 0, and notice that the ones repeat, so I only need to list them once. So I've listed all of my inputs and my outputs for each representation. Last two examples of domain and range, and I just want to show you these because they're a little bit different because these contain arrows on them. So here you can see that we have a line with arrows that continue, and what these arrows are implying are that this graph goes forever this way and forever this way. This graph continues on forever in the direction of those arrows. So if we're going to sit down and think about, okay, what are the possible x values that we need to make points on this graph? Well, essentially what's happening is this graph is going forever to the right and forever to the left because it's angled and it's going up and down, right and left forever. So if you have something like this where you have x values and you're going forever in both directions, what this is telling you is that you're using every x value that you could possibly use on this graph that continues forever in both directions. So what you can write instead is that your domain is all real numbers. You are using every possible value for x that you might possibly need. Everyone, from -infinity up to infinity, you're going to use everyone to make points on that graph because it continues forever in both directions. Now here again, because this line is angled, I notice that I'm going forever up and forever down. So again, I have this situation where my y values are going forever up and forever down, which again is an instance where it's telling me that I need all real numbers for y to make points on this graph. And the final example down here at the bottom, I'm going to erase a little bit of this to get it out of the way. This one, what I notice with x is that this graph is continuing forever this way and forever this way. So if I'm focusing in on x, I notice I'm going forever to the right and forever to the left. That's what those arrows are implying. So my domain for this particular graph is simply going to be all real numbers because I'm going forever to the right and forever to the left. Then from here, if I look at my range are all of the y values that I need, and what I notice down here is I have a little point down here that seems to be important. That's where it changes directions, and that acts as a low point for y. And then what I notice is this graph is going forever up. So if I'm focusing here on the y-axis, I'm starting down here at 5, and I'm using all of the y values that are going up. So what that's telling me is that my range, all of the y values that I need to make points on my graph, start at 5 and then work their way up. So my range would be y is greater than or equal to 5.